about reactive programming and why we actually need reactive programming. And next, I'm actually going to show some real working examples with reactive programming, the library called reactive extensions. That's actually one way that you use reactive programming in your source code. And next I'm going to talk about a thing called reactive manifesto. It's like another manifesto similar to Agile manifesto. So the only difference is that it is applied to the context of reactive systems. That is actually different than reactive programming, reactive systems. Whereas reactive programming is program paradigm, and reactive systems actually describe some architectural characteristics that should be there in reactive systems. And next I'm going to talk about how reactive programming can be applied to the context of reactive microservices. So, first starting off with reactive programming, I would like to talk a bit about asynchronous programming. So why do we actually need asynchronous programming? And what's the opposite of asynchronous programming? Which is synchronous programming? In synchronous programming, I'm sure most of you guys have already used asynchronous here as well. So in synchronous programming actually, you keep executing line after line. When the program actually requests data access from the database, so it requests the access from side files, so the thread gets blocked. So to prevent that, we actually use asynchronous programming. That's one use case. Also, it is also used to parallelize tasks, break the task into several sections and do it parallelly and to get the results. But opposed to the synchronous way of doing things, in synchronous way actually we get things as a return from a method call, but in here, we do things from a callbacks. The one call example is using Ajax. And also in the backend, also if you have worked with Node.js and those kind of things, it is used to utilize the CPUs and all the system resources better, when it comes to work that requires a lot of I/O access. So, but the problem with asynchronous programming is that sometimes it can make the code complicated. It's mainly because of the technical limits that are there in the existing programming languages, which are even in the last presentation we talked about intrinsic complexity that we can't actually prevent. So because of that, sometimes the code can actually result in an independent callback error, which means nesting callbacks inside one another. In a sequence, so in synchronous programming you execute lines in a sequence, but here when we get the results from multiple, let's say word DBSs, we end up getting a callback error. So because of that, the code maintainability and readability and those kind of things drop down, so it becomes a bit more difficult, and sometimes because of that, sometimes it becomes difficult to debug, and the system could reflect quality. Alright, and also in various programming languages, to overcome the difficulties of asynchronous programming, they have introduced many features. In JavaScript, they have introduced promises. But promises too is that promises. Inside the promise, we can create promise object, and inside the promise we can put the code and we can easily resolve or detect and get the value from the asynchronous callback. So we can just keep on chaining responses and do those kind of things. And so in C# also they have in the study version 4, I think, they have introduced two tools like Async and Await that will let you code in a synchronous way with asynchronous things. So, and also in Java also they are features called futures and computable features. And but similar to all this approach, reactive programming is actually a different approach. With reactive programming, you can do things different than these ways. So there are so many ways that you can actually use reactive programming in your source code. First is that you can use a reactive program language, and there's a new language called Elm. Actually, Elm is actually a language that's actually a platform that runs in the backend, and when you can write in a functional reactive style, and when you request something for the browser, it's actually used to develop web applications, and the function is converted to JavaScript and you get it in Frontend. So, and also it has similarities to MVVM frameworks like AngularJS and ReactJS and Ember.js and those sort of things. It uses a special pattern called module view and update. So we have to have at least it supports. Sorry, should be written in this particular format. So the other approach is that we can use a library to overcome the limitations of the existing programming language. So one such library is called Reactive Extensions, or Rx for short, and it has also characteristics of functional object-oriented languages. So I'll explain how these characteristics will be applied in that language. And also like if we compare between object-oriented, procedural and reactive paradigms, those three are different from one another. Actually, those three paradigms actually introduce three different ways of thinking. In object, like in procedural, as you all know, we deal with the basic control flow. And in object orientation, we actually take one step further by like encapsulating the logic inside classes, and also like reusing using like inheritance and those kind of things, using code. So, and also, but like different than those two approaches, reactive programming, we deal with asynchronous data streams. Okay, I'll explain what the asynchronous data streams later in my slides. So, and also like in, as you can see, like for procedural programming, we have flowcharts. And in object oriented, like as a diagram, we have class diagrams and all sorts of other UML diagrams. And also similarly, in reactive programming, we have marble diagrams that will actually show some behavioral characteristics of the language. And also like whatever the paradigm you use, whenever you write code, the code should be like readable. It should be like readable by humans actually. Like it should be like maintainable, means like you should be able to make changes, you should be able to add new features, and you should be able to remove features without any problem. Those kind of characteristics should be there, and also should be reusable, instead like should be duplicated, and also it should like work without giving any bugs or anything. So sometimes like if we use asynchronous coding with the existing paradigm, sometimes meeting this criteria is a bit difficult. So those limitations can be overcome using reactive programming. And also like if we use reactive extensions, which I mentioned previously, which is a library that we can actually use, we can overcome those difficulties that we encounter in asynchronous programming. So if we talk about reactive extensions, it has like three main building blocks. So the first one is called observables. Like as I mentioned in my previous slide, this reactive program represents a marble diagram. It's also like it deals with asynchronous data streams, similar to we deal with the things that we deal in object orientation, which are objects and classes. And here observables actually in reactive extension represent that asynchronous data streams I mentioned before. So actually the asynchronous data streams actually has a set of events that are ordered in time. And also like it has characteristics similar to a queue, and queue is actually pull-based and push-based. Okay, I'll be talking about that pull-based and push-based characteristics later. And also there's the other kind of building block that is there is called operators. But in operators, what we do is that when we get an item inside an observable, we get that item, modify an item, and return it in another observable. So actually events in this context are kind of immutable, similar to functional programming. That event cannot be changed, but it can like create a new event based on that. So it will be a sequence of like observables. Like as you can see here, like everything in reactive extensions are like a stream. Like we actually deal with streams here. So like when we have like multiple observers running, we have to like utilize all the cores. So with schedulers, we can actually utilize all the cores in reactive extensions. So, and there's another concept called observers observer. As I mentioned here, like the main building block of reactive extensions is that is called the observable. Here actually, like if we take this cricket match as an example, and suppose that you are watching this cricket match on TV, and these players are like observers. Whatever the players do are like events. Let's say like when a player hits a four and you started cheering, the cheering is a reaction. So similarly in reactive programming, you respond to those reactions in your code. So like actually this also has like similarities with the object-oriented observer pattern. And also the difference is that we actually focus more on the observable, the one that we are monitor the changes. And like actually this diagram actually shows how to use reactive extensions in your code. First, you can actually create an observable. You can actually create an observable by binding a particular user control to a observable. Like if so for example, if a user keeps on clicking a button, the button click events will be moving inside the observable as event stream, but the events are ordered in time. The first click goes first, and the second one second, and so on. And also like you can also monitor arrays and object changes. Like even if the object keeps changing, that will trigger a set of events, and that will move the events one by one through the observable. And also like we can also listen to timer intervals. Like if we put a time span, it will trigger one event after another and move one by one through the observable. And also like there are promises through which with JavaScript promises and Java features also you can create observables. So like those are actually very few ways of we can create observables. Actually there are so many other ways also. So if you like go to their site, you can find so many other ways. So and also like once you create an observable, you can actually make modifications by applying operators to that observable. There are like different so many kinds of operators. For example, transform is one operator that actually modifies that object and creates a new object. Like as actually I have shown a small syntax down there. First method actually creates observable by binding it to text box, and then it actually applies the map operator. What it does is that the event actually sends a JSON object inside inside the observable, and then the map function actually removes all the unwanted things and gets only the required value. And like then we apply the distinct, because observable always when you apply a operator to the observable, it always returns another observable. So we can keep on applying operators. So and filter operators are also there, like you can filter out all the unwanted things, and also like you can apply mathematical things like maximum, minimum, and those kind of things. And also you can also like whenever there are like one or more, two or more observables, you can combine and create one observable. And also like how do you react to changes inside an observable? You have to subscribe that to and you have to get events one by one coming inside the last observable that is there in the chain. So actually you have to use the subscribe method, and inside that you can like here actually I am printing each item one by one that comes to the observable. So items can come at any random time because observable is always as asynchronous. So and also like whenever there is an error, we can get the error will be printed here. And also like whenever an error occurs in any of the observables that is applied, let's say that is like doing some sort of transformation or anything, it will trigger that error method. And also like once the observable completes, our observable can be like low on running or completed. So once it gets completed, it will trigger that last method. And the other concept in Rx is that pull versus push. If you get a traditional like queue or something, but it's actually a pull based thing. You get the data structure from like your memory or something, and then you keep on applying whatever the operators, and then you do whatever the calculations you need. And but opposed to that, reactive extensions, the observables in reactive extensions are pull based, which means that that responds to changes that happens inside that observable. So like if you look at these two, like the program syntax looks pretty much similar, but this part is actually a functional method that we use here. We put a lambda expression here, and then we do the calculations here. And also like what we do is that if you look at this requirement, it actually is like we have an array, like we have to like filter out all the even numbers and multiply all those things by 2 and print all the numbers. So here actually if we do it in traditional way, whenever we make a modification, we have to do the calculation manually. That is pull based. So if we do it in a reactive way, whenever we make a change, it will trigger that subscribe method, and we can react to whatever changes that you need. And also here the method chain is synchronous in functional way. Like this, when you apply whatever the operator, it returns another array. So you can have to like keep on applying it, and that is kind of synchronous. But here it is very asynchronous. Like when you apply filter, it returns an observables which you can monitor. And at the end of the chain, you can subscribe to that observable. So that's like the main difference between that. And also like there's a thing called marble diagrams. Marble diagrams actually represent the behavior of various operators. Like there's one operator called filter that actually filters out all the unnecessary things. So and those are actually methods. There's a cool site called RxMarbles.com, and in that you can actually simulate so many marble diagrams that will make it very easier for you to understand the behavior of those kind of things. And also like there's another operator called maximum. So actually in marble diagrams, the vertical line at the end actually shows the completion of the observable. So at the completion only, the maximum value will be calculated in this max operator. And also like you can combine two operators together using the merge operator. In merge operator, a final observable will be outputted with the two things that are combined. So let's just I just want to show some working example of RxJS. So let's say that you want to do some sort of autocomplete. So here actually, whenever we enter something in the text box, we should like make a REST call and query the database and should show it to the user. So like if we keep on sending requests to the server every time when the user makes a change in the text box, that will result in so many unwanted service calls. So to prevent that, what we can do is that we can like add a time span, so time interval, and then within that time interval, if the user has made any changes, we can send the request to the server and get the data. So in reactive extension, there is a special operator called debounce. In debounce operator, what it does is that it actually in that particular time span, it will filter out all the last elements and like emits only the last element in it. So like you can see the behavior in this marble diagram, and also, and if you look at the source code in JavaScript, first it gets the text box, then like it binds it to the event and creates an observable, and in the stream we are applying the debounce operator with 500 milliseconds of delay. In every 500 milliseconds of delay, if a user has made any changes, it will send a request to the server. So actually I didn't include the service calling of the Ajax logic here. So let's suppose that the search method over there inside the subscribe calls that thing. So, and once it's completed, it will output that. So see how simple it is. Like that will always keep your code more organized. Like we will make it very easy for you to make changes, and it will meet the criteria. And you can also like do very unconventional coding, like respond to unconventional events like triple click. In triple click, actually, what we can actually do is that we have to see whether the user has clicked a particular control 3 times within a particular amount of time, and we can apply the operator called buffer with time and count. But this operator, unfortunately, is not there in reactive extensions. It doesn't come with reactive extensions. But what you can do is that you can create your own operator. So this is the one custom operator that I have created. So like I'll share you the link at the end of the slides so that you can check that out in GitHub. So like, and what it does is that if we apply a time span and now a count, it will trigger triple click event if the user clicks it in 3 times in 500 milliseconds. And also like you can write custom operators in RxJS. Like for example, if you write in JavaScript, you can modify the prototype function and add operator and write the logic inside it. And also similar to that in C# also you can use extension methods. And also like in JavaScript also there are like necessary interfaces like observable and transformation, I think I can remember. So, and also like next I want to talk about reactive systems. Actually reactive systems are different than reactive programming. And reactive systems actually describe a set of architectural characteristics that should be there in reactive systems. Reactive systems. So, whereas reactive programming is a programming paradigm that actually defines style how you should code. So, to define the characteristics of reactive systems, there's a thing called Reactive Manifesto. Yeah, you can just visit this site and read more about it. And first, actually, in Reactive Manifesto, and at the beginning, actually, they mentioned about the systems that we used to have those days, and it mentions that the number of servers are less, and also it has a very low amount of data, they're measured in gigabytes, and has like 1 hours of maintenance time, and also less some seconds of response time, and so on. And however, those systems are not applicable for today's requirements. Like today's requirements should have like milliseconds of response time, and should like the data should be measured in petabytes, and should like be deployed in like cloud, mobile, and those kind of multiple platforms. So, however, according to the Reactive Manifesto, today's demands are not measured by just the software architectures. So, Reactive Manifesto actually defines a set of architecture characteristics. Those are called responsive, elastic, resilient, and message driven. That means that in Reactive Manifesto, it says that to make a system reactive, these characteristics should be met in the software architecture. So, actually, if you take the first 3 architecture characteristics, which are responsive, elastic, and resilient, and those are like the non-functional requirements that you get in a system, or also the quality attributes. And the message-driven characteristics represents how the components should interact inside the reactive system, which is by sending asynchronous message passing. And Also like elasticity characteristics means like it should like adapt to the changing workload of the servers and should like scale up and down according to requirements, and resilient means like the system should have the required level of availability, and the responsive here is actually not the mobile responsiveness that we usually talk about. It is like having the low response time and low time to repair the system. So yeah, so like and like those things can be achieved using the message passing characteristics. If we use asynchronous messaging, these three characteristics can be applied according to the reactive manifesto. So also like if we use asynchronous message passing approach, we can isolate the components, we can have a loose coupling, and we can also achieve a thing called location transparency, which means like whenever we issue a call to another component, the issuer doesn't know where it is hosted, which is known as location transparency. So those kind of things can be achieved. So like, okay, now that's the difference between reactive programming and reactive systems, which are like, as I mentioned before, reactive programming is a programming paradigm, while reactive systems are a defined set of characteristics that should be there in modern architectures. So, and however, like if we combine both approaches, like reactive programming and reactive systems, we can build better systems with better maintainability. So like as mentioned before, here actually reactive systems also we communicate using asynchronous message passing. So what happens if we use asynchronous coding in our code? So the code gets more complicated. To prevent that, we can use reactive programming. That's what I call this more maintainable when I say it better. So like if we get another software architecture like microservices, it can be altered to have reactive features, and that architecture is called reactive microservices. And if I talk a bit about microservices, actually microservices are different than traditional architectures. Like you just break the application into smaller amount of services, and you can have those small services running inside a Docker or some sort of a containerized environment, or you can run it as a process like Node.js or Java, and you can have multiple processes running inside the machine, and those services can also have its own database. The database can be SQL, it can be NoSQL, and so on. So however, like traditionally actually we use HTTP REST to like communicate between microservices, but in reactive microservices we use asynchronous message passing. And also like reactive microservices should also like meet these requirements, like the functionality should be isolated from each other, and also like it should be like autonomous, like whenever it crashes, like it should impact the whole system, and also like it should have a single responsibility, like the functionality should be duplicated, and also like the state also shouldn't be duplicated, like it should have a separate database to keep its state and so on. And also like actually these characteristics are already there in the traditional microservice architecture, but what differentiates that is the asynchronous message passing. So, and also like, but how can we apply asynchronous message passing to reactive microservice architecture? There are like so many approaches. We can use a middleware like RabbitMQ or Kafka or something like that. Using that, rather than like communicating between microservices using REST or some other protocol, we can use a specialized protocol like AMQP that comes with RabbitMQ, or you can use a message broker like Kafka, and also like we can use messaging libraries like ZeroMQ. The difference between that ZeroMQ and RabbitMQ is that ZeroMQ is actually a brokerless architecture. It actually comes as a library. And also like we can also use event-based communication between components by using something like Vertex that actually is a event bus, and also like we can use like actor-based libraries like Akka, Plain frameworks, and also we can use Node.js for asynchronous programming. And also like there are also like specialized microservice architecture called Legom and Eventuate that actually utilizes a pattern called CQRS and event sourcing. And also like even though like we can do like so many things with asynchronous programming, and we can especially like we can also achieve the objectives of reactive manifesto, but still it leads to more complexity. So like I would like to also talk about an example of reactive microservices. But in microservices, like as I mentioned before, services are deployed separately and like exposes separate endpoints that can be accessed by the UI. So like let's say like we are operating our system in a very slow connection. So what we can do is that we can issue only one connection rather than calling everything, which is called backend for frontend. And with that backend for frontend, you can call all the other service services, and then you can present the results as one to the user. The other advantage is that mobile and desktop, web clients have different backend front ends that will suit the data needs of those, and that's actually similar to the Faka design pattern. So, like if it so for the example, the requirement is that let's say there's a backend front end that exposes a REST endpoint that can be accessed by a mobile or a web browser, and the backend front end actually accepts a list of custom IDs, and the service should filter out all the customers younger than 30 years. So, since we are only getting the customer IDs, we have to call the customer service and query the database and get the customer ID. Then we have to check the account balance of those kind of things, customers. Let's say like one customer has one account, like let's suppose that it's a mobile service provider, that there are so many customers, and like each customer can have many accounts. So, here actually the customers can be stored in a different database, while accounts can be stored in different database. Like if you use SQL, we can easily do a inner join or something and combine the data, but in Reactive Microservices, we have to make a set of service calls. And suppose that we are coding this in a very asynchronous environment. So, if we do something like that, we can result in so many callbacks and so things like that. So, to prevent that, we can use Reactive Microservices. So, for example, in here what actually happens is that this is actually the source code of that example. See, there are no callbacks, everything is like written in a method chain, so the code is more maintainable and more like reusable, and changes can easily be made. So, that actually makes your life a lot easier when it comes to changing and any of those kind of things. So, here actually what I do here is that first when I get the custom IDs, I get first I generate the URL, and then I issue a HTTP GET command. But actually here, as I mentioned previously, HTTP GET command doesn't come with reactive extensions. What I did was that I wrote a separate operator. So, like you can also like encapsulate all your logic inside operators. So, here then once you get the objects one by one, we filter out all the customers and oh, sorry. I just made a mistake. I'm so sorry about it. Thank you for showing that.
This is beautiful. This is functional programming.
Yeah, exactly. Yeah, it has characteristics of functional as well. That's the beauty of it. Even though it looks like functional programming, this is asynchronous. That's the beauty of this. So, and like once you get it, like we can subscribe for everything, and here actually we can append everything to an array, and when once the observable gets completed, we can send the account list as objects to the front end. So, that's the basic idea about it. So, like I also want to mention the other thing. HTTP protocol is synchronous by nature. What if we want to put asynchronous thing over there? We have to write a separate operator. Like for example, if we are using RabbitMQ, it uses a different protocol. And also, like if you use a different protocol, like asynchronous protocol like RabbitMQ, we can issue a request and to another component, and we can asynchronously get the results. To do that, we have to like do a technique called like including the correlation ID with the request, and in the response also we are getting the response to the correlation ID, and we can combine the request and response to that correlation ID and do that. So, those kind of techniques can be done. So, and also we can combine with multiple protocols as well. So, that actually ends my presentation, and also like with reactive programming, your asynchronous coding makes it a lot easier, and you can also write more like reusable and more readable code, and also like building more modern applications becomes simple. So, like if you like visit this link, you can get all the source codes from the GitHub, and also the custom operators I have written, those are available in that link. So, thank you. Any questions?